Differentiation of algebraic functions is just the process of finding the derivative of a function. So this is the operator that we use for differentiation, dx. It's just like the square root operator. So if you have y equal x squared and you want to use the square root operator to find the positive square root of both sides, we get square root of y equals square root of x squared. Then this will give us square root of y equal x. The derivative operator also behaves like this: d dx of y, so we are operating on the function y equal x squared, equal d dx of x squared. Then if you have something like this, you write it as dy dx equal 2x. So in short, dy dx of x squared, dy dx of y equal x squared is 2x. And don't worry about how we got this for now, but this is what we refer to as the derivative function, or the derivative of y equal x squared, and it is also called the gradient function or the slope function of y equal x squared. It is also used to find the rate of change of the function of a given function at a given point. Now let's look at how we use. Now let's consider the rule of differentiation. If you have y equal x to the power n, then it can also be rewritten as f of x equal x to the power n. In this case, the n is a constant. So the rule is that to find the y dx of this, use the power to multiply the whole thing. Then subtract 1 from the power. The same thing applies to this, but the notation is f prime of x. So f prime of x is the same as dy dx. Again, the rule is that use the power to multiply the whole thing. Then after that, subtract 1 from the power. For example, if you have y equal x cubed, you use 3 to multiply the whole thing, 3x to the power 3, then subtract 1, so minus 1. Then simplify the result to get 3x squared. If you have y equal x squared, the same thing, use 2 to multiply the whole thing and subtract 1. So you are going to get 2x to the power 1, then this will give us 2x. Always remember to simplify the result. Then if you have y equal x to the power negative 1, the y dx will be equal to negative 1 multiplying the whole thing, then subtract 1 from the exponent. So this will give us negative 1 times x to the power negative 2. Then simplify the result to obtain negative 1 over x squared using the laws of indices. The derivative of a constant. What do you think will be the derivative of y equals c? Now y equals c can be rewritten as c times x to the power 0, because x to the power 0 is 1 and it will give us back our c. Now we apply the same rule. So 0 will multiply the whole thing, then subtract 1 from 0. And this will give us 0 times c x to the power negative 1. Now 0 times anything is 0. So if you differentiate a constant, you get 0. Any constant at all. So if y equal 1, dy dx equals 0. If y equal negative 1, dy dx equals 0. If y equal 59, dy dx equals 0. In fact, any constant you can think of, dy dx will give us 0. Now, the rule applies to a function of the form ax to the power n. For example, if you have y equals 6x squared, dy dx will be 2 times 6x squared minus 1. So this will simplify to give us 12x to the power 1, which is the same as 12x. Remember that the exponent will come and multiply the whole thing, and after that subtract 1 from the exponent. We can also differentiate term by term. So if you have y equal x cubed minus 3x to the power 5 plus 3. Now note that this is having 3 terms, so we differentiate each of them one by one and put them together. So we differentiate x cubed to get 3x squared. Then we differentiate x to the power 5, that is 3x to the power 5 to get, you see 5 will multiply the whole thing to get negative 15x to the power 4. And if you differentiate 3, you get 0 because it's a constant. So the y ds of this is 3x squared minus 15x to the power 4. Now there are so many ways that you can be asked to differentiate a function. The first one is find the derivative of. The second one is find the y ds of. The third one is find f prime of x of f of x equals something, or calculate the rate of change of y equals something, or find the gradient of y equals something. Now let us take some examples. We have y equal x cubed minus 2x squared plus 1. Find the y dx. So y is equal to x cubed minus 2x squared plus 1. And you want to find the y dx. So the y dx will be equal to, so this is 3, so we will use 3 to multiply the whole thing, subtract 3 minus 1 will give us 2, then minus, so this is x to the power 2, so we use 2 to multiply the whole thing, 2 times 2, then x to the power 2 minus 1 is 1. Then this is a constant, so if we differentiate a constant, we get 0. So we simplify this to obtain 3x squared minus, this will give us 4 minus 4x. So the correct answer is B. Find the derivative of the function g of x maps onto x squared minus 1 over x cubed. Now we know that you can rewrite this as g of x is equal to x squared minus 1 over x cubed. So we can rewrite this like this. So g of x is equal to x squared minus x to the power negative 3. So we use the laws of indices to write this as x to a given power. So now we can, derivative of this function is given by g prime of x. So g prime of x will be equal to, if we differentiate x squared, we use 2 to multiply the whole thing and subtract 2 minus 1 will give us 1. So 2x to the power 1. Then minus, now we use this to multiply the whole thing, we get negative 3. Then x to the power negative 3 minus 1. So this will be equal to 2x minus will give us plus. So 3x to the power negative 4. So we simplify this to obtain our g prime of x to be equal to 2x plus 3 over x to the power 4. We use the law of indices again to simplify this. So the correct answer is B. Now if y equal to 2x squared minus 2x plus 1, find the value of the gradient of the tangent to the curve at the point where x equal negative 1. Now we know that if you have a curve, we know the tangent touches the curve at only one point over here. So at this given point, the tangent gradient is equal to the gradient of the curve. And we know the y dx gives us the gradient of the curve at a given point. So when we are asked to find the gradient of the tangent, we are simply find the y dx of this function. So we know dy dx will be equal to, we have 2 already, so 2 multiply the whole thing, 2 times 2x to the power 2 minus 1, which is 1. Then minus this one is 1 times 2x to the power 0, because 1 minus 1 gives us 0, which is 2. Then if we differentiate the constant, we get 0, so plus 0. So this is the same as 4x minus 2. So at x equal -1, we have dy dx. This is how we write it. Dy dx at x equal -1 means that we substitute x equal 1 into the gradient function. This is the gradient function, which is 4 into -1 minus 2. And this will give us -4 minus 2. So this will give us -6. So the correct answer is -6.